contribute to improve the patient outcome. Throughout her career, Dr. Gupta has been actively involved in research, academic mentorship, and implementation of advanced techniques in emergency settings. And her contribution to the field have not only enhanced the diagnostic accuracy, but also streamlined the laboratory operations to support the effective decision making. So it's our honor to have Dr. Gupta with us today. Her insight and expertise will undoubtedly add great value to our discussion. So everyone, please join me to welcome Dr. Parul Gupta. Ma'am, welcome and thank you once again.
Thank you, Dipti, and thank you for giving me this opportunity. I got week before a message from Diksha regarding this webinar.
Yes,
So I was thinking, how can I contribute to this? Then I later means realized that there are many problems which are faced by the lab technicians, especially the persons and doctors who are running the labs regarding the quality controls and maintaining the quality of the reports. So, like we also do here in GTB, and GTB has a huge rush of patients and population. It's like means we are dealing with about more than 700 samples daily on daily basis. So it is emergency lab is 24-hour running laboratory there. So, and basically, I am a biochemist and dealing with the clinical chemistry parameters. So, today I would like to share the experiences and today's, these are just like my experience, not a lecture actually. So,
yes,
this is like
absolutely.
what I experience in the laboratory and how come I get through the problems to it and how I'm trying to maintain the quality because what happens when the analyzers are running 24/7 no? So there are so much rush of the errors everywhere, might be pre-analytical, analytical or post-analytical, and basically I'm just means sorry to say, but government hasn't realized that we don't have LIS, so that is also one of the main cause of the error. So on every point we have to check that errors. Okay, so in such a laboratory which is full of errors and running IQC and ECAS in such a laboratory is like managing a big task with error-free ECAS runs. So initially, like we have started about 6 months before ECAS in our lab. That too, we have to mm, means fight for it very much because government is like it is already running. Why we need ECAS? But we have to make them understand why it is necessary, why cars is necessary, why controls are necessary. Hey, you are running IQC, why you need a cars? So
Absolutely.
we had to explain that we have to check with our peer group also that how much accurate reports are they are getting and where we stand in that means pool of the group. So later they realized and we started running. So we come across the many sort of problem. And today I'm just means sharing how we take means corrections to the means these all the problems which we get through while we get the cast reports. So shall we start? Can I share my
Yes,
screen? Yeah.
yes, ma'am, absolutely.
Thank you.
Thank you for the insight, ma'am. Yeah, this is, I think, very much needed for every laboratory.
Yes, yes. And actually, it is on day-to-day basis. If you are a means learner also, and if you are like running a laboratory, so you need these things very much. And somehow people learn from their own mistakes, right?
Yes,
So
absolutely.
if somebody give you support from their whatever the knowledge they have gained from their mistake, then it is like a means boon to them that means they don't have to waste that much time over it.
Absolutely.
So in my lectures today, I will be covering the corrective and preventive actions for ICAS, basically for clinical chemistry laboratory. So, as we know, corrective and preventive action, what it is known as CAPA. CAPA means CA stand for corrective action and PA stands for preventive actions. So corrective actions means sometimes what happens when we run a sample which we have received from external for external quality assessment scheme. So after that, when we get the report, means our IQCs are fine, all the level IQCs are fine, and everywhere we have means like we are tried to do error free run for that course. Still we what the report we get, that is like have many errors, might be the SDI is above -2 or +2. So on that basis, on that report, how we have to work to correct our report of ICAS, so that we will be discussing through it. So, like here we can see, I have taken a cast report from my lab only. So here we can see, I'm starting with the example of a report. This is the cast report, and we have some parameters which are having flag. Flag means the SDI, that is standard deviation index of these means results are more than -2 or +2. And there are some parameters which are alert, means they have the SDI index more than 1.5 or -1.5. So if we start with these parameters, sorry. So first of all, if we try to check these parameters, see why these analytes gone above or out during the result. We want to know, we want to check it. So for that, we have to start with the corrective action. How do we correct these analytes in our laboratory so that in the next run we don't get these out reports for these analytes. So kappa, when we start a kappa, when we start a learning analyzer for further preventing or correcting the analytes which are gone out during the ICAST run. So it is a 5-step process. It is means we have to step by step correcting each step. So first of all, the first step is to separate the analytes with the flag and alerts. So like we have seen in our reports, there are some analytes which have flags. The red triangles are showing flags to these analytes. And there are, when we see the SDI, where there are some analytes, means see -2 or +2 till +2 or plus till -2, the it is permissible. Okay, the results are permissible, but still few are near to the border, few are means above 1.5 or below -1.5. So what we have to do, see, it's three we have tracks, and like here calcium we can see it has the SDI above 1.6. So we can put these analytes as like a on a alert means group, and these are the flag group which has these triangle like flag. So when we see, when we have to separate these analytes, so we are now separating these analytes like the flags which have we analytes which have the flags like creatinine, glucose, and lipase. These are the three analytes which have the SDI, that is standard deviation index, which is more than 2. And there are some analytes which we have kept in the alert group, like calcium, potassium, and total protein. So total these three have the SDI more than 1.5. Okay, and this is the two groups we have maintained, and means now what corrective action we are have to take in these two groups, like the flag group and the alert group. So first second step is to find out the root cause, why these parameters are out, why these parameters are in the alert group. So this is known as root cause analysis. This we known as call this the root cause analysis, because we are going to the depth where might be the problem have arisen. Okay, so if we come to the root cause analysis, so first of all, in a root cause analysis, we first of all check our IQC values. What are our IQC values during the cast run of that day, or how our what picture our LJ charts are showing for these analytes basically. First, we will check that. So and then we, if our LJ charts are fine, so one by one I'm going to the next step. See, I have put a LJ chart picture here. This is a total protein LJ chart picture. So I think total protein was in our alert. Okay, fine. So total protein was in our alert group. So here is the LJ chart picture of the total protein. Anyone from the past participant can tell me, these are these LJ charts are fine, or are they are error free, or they have some error? Can anyone can suggest? First chart is of control 2, and second chart is of level 3, control level 3. So control 2 is a level 2 is the normal level. And what we see that our values are deviated towards the lower side. And from continuity within means like 20 days of the values, we are going to the lower side. Okay. So when the values are shifting to the lower side, okay, see, might be suppose I had run a equals on the means on the day of 29th or 27th. The value of that day, the value is fine. It is within mean. This is the mean line, and this is -1. So the value was fine that day. That was between the mean and -1. So that is permissible. Okay. हमारा out नहीं गया. It is not out. It is permissible value. But what happens? But it is coming in the alert group during the cast run. So now we have to check the LJ chart, that what happened. Our IQC was fine that day, but what happened that protein total protein is in the alert group. So what we see that the level 2 control, well, if it I am coming to the level 3 also. If we see the level 2 control, the graph is going to the lower side continuity till from last 20 days the values. So this is a kind of systematic error, means graph is deviating from the mean only to the one side. So this graph is not right actually. This is not a permissible LJ chart graph for the means any analyte. But for the control to, the most of the values are on mean, above the mean also and below the mean also. So this is the permissible graph. So for level 2. So now we check the value of the PICAS chart. So if we see the total protein in the ICAS chart, we can see it is level 1 or level 2. Okay. And our level 1 is not coming fine in it, but here the level is going below side or above side in the total protein. But if this total protein was of level 2, then we could have predict that the total protein is going the lower side. It could have matched. We can take another graph also like that. Here the one more graph, it is of glucose. Okay, so here the glucose chart, we can see control 2 and control 3. Okay, glucose is in our flag group, and flag was in the plus side, that is 3.35 was the SGI. And if we check the value of glucose value was on the level 3, means higher side. Okay, so here we see, observe the graph of this glucose. This is total protein, this is glucose. So we can see the values, the chart, there are means chart is fine. Okay, this chart is accurately fine because no deviation is there. Both the side we can see the values of the chart in the both of the controls, like in control 3 and control 2 also. Okay. So if such charts are there where the means LJ charts are fine and IQC values are there fine, that time we have to check for the second thing in the root cause analysis, that is check the last calibration date, when the last it was the calibrated, when the last analyte was calibrated. Might be the analytes needs calibration, might be there is the deterioration of the reagents, might be there is something else issues are there which due to which the IQC is fine, but when it is compared to the peer group, that time it is means result are out in the course. So we check the calibration days and we have to match that when it is last calibrated. Okay. Second and last thing we have to check in the root cause analysis, that what I have done, might be other labs are doing many other things also. So what I have done, that I have also checked for the reagents last dates. What was the last date when the reagents were changed? Might be reagents might be up to the finish level when our records are run. So that time the reagents are deteriorated, and that's where IQCs are fine, but might be the other people in the peer group has the better reagent from us. That's why the mean from those peer group is means like better than ours. That's why our result is deviated. So that can be the cause due to which ICAS is out. If all the three things are fine, suppose all the three things are root cause analysis fine. So for systematic error, one has to call for the engineer. Why there is a systematic error? Okay, there are many causes of systematic error. So that we can check by, that can be checked by the engineer. Might be light source is not working well, or there is like means some temperature issues. Okay, so if there is a temperature issue, then there is a deviation of the means enzymatic analytes first, like AST, or ALP or LDH. They can give means the picture of means like deviation of the IQC. So that's where we can check whether the means what is the root cause of particular analyte for because of which the ICAS values are out. Okay, so first of all, we have checked. Now we are coming to the lipase. Lipase was in our alert group. Lipase was like sorry flag. Lipase has given the flag, and this is the means chart of the lipase. Now what we see that control 2 is fine for the lipase, but control 3 is showing the systematic error. Okay, so when we have checked that it is giving the systematic error, why it is giving the systematic error? Why? What could be the reason? Then we went for called the engineer regarding it, and we come to know that the lamp source is not fine for the lipase, and since lipase is the enzyme and it needs means proper wavelength for the lamp, so that wavelength is not matching to the criteria, so we have to change the lamp source to get the lipase results fine. So that could be the reason why the lipase was out. Then second, we can see that after that, when we have done the that lipase corrections, next is we went to the root cause analysis. We have checked LHR reagent change. We have called the engineer if there is some systematic error, or there is the machine needs to be changed for the lamp, or cuvettes need to be cleaned. That has to be taken. And next step for it, now what action we have taken? Means the action here we have taken, we have tried for the rerun of the equas, same sample equas, because when we allocate the sample now, so means it is somewhat the sample is left. Okay, so we have to means keep this sample in a storage, and we can rerun this sample. So what action we have taken? We have calibrated the parameters, and then we have done the IQC levels of all the levels, and then we have rerun the ICAS. That is the action we have taken for that particular all the analytes which are giving flags or which were giving the alerts. So after rerunning the ICAS samples, now we have to check whether the results are better or not. So these comes under the observation. Okay, so for these analytes, what we have found when we have gone through the root cause analysis and followed all the actions through the root cause analysis, after rerun, most of the analytes showed the improved result. Means their values were more near to the ICAS mean. Okay, so that was the observation. So now again, we can interfere with the result that how was the ICAS rerun, whether it was improved, whether it was more deviated, or whether it is deviated totally, means there are some analytes also which have means first of all they were giving the higher value, later in the rerun they were giving the lower value. So that deviations are also there, can be happen. So this is the observations which we make out, and we can interfere the. But tell you what, with my experience, I have seen if we check for the root cause analysis and and done the rerun of the equals, most of the analytes have given the better result and improved results for the and for those which are gone out or which have gone to the alerts. So the rerun of the equals for me has given the improved result for most of the analytes, and few which might have not given the means improved result can be because of other means sources, might be technical sources which can be means giving the clear application engineer can give the clear picture regarding it, for which we are not at all efficient. That only can be engineer can application engineer tell. So we called application engineer for those which are totally deviated from the rerun of the ICAS, and they have solved our problem. Might be there is might be the temperature problem also, or sometimes it happens with the problem with the storage of the reagent also. So there might be some lots which have the storage problem. Like recently what we found from the LJ chart, that our urea has to be calibrated on the daily basis from evening also, and means morning also, since last 20 days. So after looking out for everything and for the checking of the means method is urease method for the urea, and checking for the at what temperature and what wavelength that urea work, that is urease method working, that is 340 nm. So whenever a light source gives a problem, this wavelength first give problem, that is 340 nm wavelength give problem. Okay, so when a light source give a problem, first of all SGOT and SGPT get deviate deranged results. So that is means like if your SGOT and SGPT are giving the means deranged result or deranged or out IQC on daily basis, might be the there can be the problem of the light source. So this is the one of the indication of the light source. But our light source was fine and it was checked recently. Then we went to the lot when the lot was changed. Last lot was changed. So it was changed since last 20 days only. It was changed, and we find that lot gives 2 or 3 days, it goes fine, and later it goes, means the results are out, IQC results are out. So we have to calibrate, and again it comes to under the means within the 1 SD, but again next day it again goes out. So laterly we find out that that lot has a problem, that lot has a problem, but how that what the lot has problem, somewhat sometimes what happens, Company means supplied a lot, but there is the storage issues with the lot. Means the dealer might have not stored those lots properly. So that's why, since it is an enzymatic method, you raise. So due to the storage problem, the storage issue means enzymes get deteriorated and the results are not fine. Okay, so that can be the issue while the means during the running of those analytes. Next, we have to check action, observation, and result interference. We have taken, we have rerun the course, we have checked everything. Next, what is the final action has been taken? What final action we can take? Here was the lipase. Here was one analyte was creatinine. I want to discuss about the creatinine. Creatinine is like a very, it is Japanese method and picric acid method, and that is very deteriorating reagent. And mostly, I think if my colleagues are there who are working with the lab, they might be knowing that creatinine is an analyte which needs like to be calibrated on the daily basis. So you can see the picture of the control tree of the creatinine. Here you can see the values are deviated like towards the -3, then towards the +2. Means its chart is means one peak high, one peak down, then high, then down. That's why what is the reason of this? Because creatinine has the uh, most sensitive reagent and it needs to be calibrated on the daily basis. So the graphs are coming that way. So more means my fellow colleagues will agree that this is the creatine is one who gives mostly to be out from the cast result or IQC result because of the reagent issue. So when we can rerun with the checking of the reagents, then the results are fine with the creatine. Okay, so that's the problem with the creatine. And if we talk about the next, what are the final action we have to see if the results are not improved. Again, I am saying that after rerun, the results are improved means we are have solved our root cause due to which the cause was hurt. So if results are not improved, so what the final actions we have to take? We could change the reagents. As I said, there could be the problem with the lot of the reagents. So we can change the reagents and check for the rerun, or we can wait for the next cycle for the ECAS. We can replace the light source or lamp. Okay, so lamp is also one of the problem. Next problem, which can be arise mostly, that is the cuvettes are not clean. That's why might be there is now not a proper transmittance of the light, due to which the analytes are giving not a fine results for IQC. And if IQC are not fine, of course reports are not fine. And still all the three things are means are going fine, you can call engineer. I don't think after solving all these issues we need to call engineer, because sometimes what happens there, the problem can be set with the means what are the means for IQC you have taken in your lab. Means if you are running the IQC with the manufacturer mean, so by the enable it is like means suggested to go to the lab mean instead of the manufacturer mean after a month. So that way you can see that when you assign a lab mean for IQC, the picture of edge chart stain. So that could also solve the problem. That way also you can check the results of your analytes ki both the way by the manufacturer mean or by the lab mean, what are the IQC values. So because the cause is always dependent on the IQC value. And finally, if still we have problem is not solved, we can call for the engineer. Okay, so engineer, because there are some things, few things might be parameter needs to be changed, reagent temperature is not maintained, or reaction temperature is not maintained. That could be the problem that will be means checked by the engineer or application engineer, and he or she can go through the exact idea what is the problem, main problem occurring after going through all these things. Okay, then last thing is we go for the preventive action for the next cycle. So what preventive action we can take for the next cycle. So this through this cycle we have learned that many things are there which can be checked for the next cycle. Like we have to monitor the LG chart to just check out whether there is a systematic errors. If there is no systematic error, still a cause is going on. There can be random error also. So that is not a big deal. If you rerun the cause, the values will be improved. And for the next cycles, we have to check for the reagent dates. Like I have told that there are few reagents which are deteriorating, and if they are long before, they are lot have long before started the cast run. So might be the reagent on which the cast is run is deteriorated. Okay, so we can check for that also for next cyclic casting, and always calibrate the analyte if it is required.
क्या रेबेका वीडियो दे रही है तू मैं तुझे अरे आज है ना लास्ट है ना तेरा
Okay,
आज मेरा देख रुक दे
so
बाद में रिप्रो दे
uh,
तू चली चली जाएगी तू सर काय आहे ऐसे दगड ओपन लोक
Diksha, can we proceed? I'm just about to finish. Uh,
yeah ma'am you can proceed.
so lastly, we should calibrate if it is calibration is required, because calibration solves most of the issues. If the IQs is out, then first step is to calibrate and rerun the IQC. And if after that we can go for further actions for what or to find out the root cause of what is giving those parameters to out of the SDI or beyond the two SDI. Okay, so thank you, and I would like to invite questions for the session.
Thank you, Dr. Parul. It was such a great presentation and such a great insight from you. And I think
Thank
there
you.
are two, three questions we have. So I would like
Okay, okay.
participants to ask questions on open forum. Yes, I think we have question from Mr. Anil Ahir that he
Yeah.
just raised his hand. Sir, if you can ask your questions here, we have a 20 minutes still.
Dr.
Are
Parul,
there? Yes, sir.
I have
Yes,
a
sir.
question. First of all, thank you
Yeah.
very much for your wonderful presentation. I think
Thank
more
you.
than Accurex, I think our partners might have gotten, our customers and partners might have gotten more information. My question is, I'm just asking on behalf of our customer itself. So
Yes,
basically,
yes.
I do like partly my answer for my question is already been covered, but I just wanted you to elaborately brief this particular point. See, most of the time, I mean, there are times when we get such a complaint from customers called there are color development and the whenever we are running the QC, the optical density is not matching. Like, can you please give our partners or Accurex team a kind of tips that what exactly we can do to avoid those errors, like how to store it, the moment we take it from the refrigerator, we can immediately test it, or we have to bring it to the room temperature before testing. Can you please give a brief elaboration about that?
Actually, whenever you are bringing the reagent out of the refrigerator, first of all, it is suggested to bring it to the room temperature, because machine itself has its temperature. Okay, and it will maintain. So when machine start with the maintenance, right? So it will check for everything, reagents also, and for means substrate, and each and everything it will check before starting for the running of the sample. So what I suggest, first of all, if it is a auto analyzer, so I don't think in a auto analyzer, if there is color development of the reagent, we cannot see in a auto analyzer, but for semi, I think we can see. So that is most probably because of the pre-analytical error. So I suggest that let the reagent come to the room temperature, then start with it. Never start with the means like cold reagents in put the cold reagents with the analyzers.
Wonderful. Thank you. I just have one more question. Like
Yes.
the IVD, reagents are absolutely fine. So Accurex has a bandwidth of point of care devices also. Is there any other particular lab for testing point of care devices like NIB, which is there in New Delhi? Like, is there any other labs where it can also be done?
Uh, See, point care testing, every lab, so few of the analytes is every lab is covering the point care testing. Okay. So it's not like for all parameters, but means like some parameters are always with the point care testing. See, when we go for this now, what, so always when a patient is needed, suddenly check for the, if it is patient is hypoglycemic or hyperglycemic. So there the glucometers are used, right? And if cardiac markers, I tell you. So cardiac markers also the means requirement like for the means diagnosis, because when we go for the analysis through liquid chemistry, it will take some time, as you also know, right? So every hospitals need point care testing. So it's like demand is according to what they are testing, on what parameters they are testing for.
So, ma'am, is there any external quality assurance for this point of care specifically, or is there any type of space? Like, for example, IVD range, there might be some separate ISO standard that is telling that you have to do the testing like this. Likewise, is there a separate standard for point of care which is given in this
Like,
EQAS?
EQAS not started right now, but tell you, but point care testing, like we have means revised ISO of NABL, right? So they have covered the point care of testing in it. They have means given one clause for point care of testing, and it is covering. And I think it will be soon means like arriving also for ICA's external quality control also, and IQC also, internal quality
So what is the
control also.
standard number, ma'am? Like in which exact ISO?
Right now, I cannot means remember, but I will share the clause with Diksha, which clause it is in NMBL for
Sure,
point
sure.
point care. Okay. Okay.
Thanks a lot. Thank you very much.
Thank you.
Hello.
Yeah.
Ah, Prashant here from Kolhapur.
Yes, yes,
Hello.
yes. Hello. Yes,
Yes,
Prashant. Yes.
yes. Thanks a lot, Madam, for a wonderful section, and thanks for accurate team. My
Thank
question
you.
is, some instrument comes in the market with calibrated RFID card, biochemistry analyzers, like
Yes, yes.
CRP, HbA1c, ASO, whatever it is. This
Mm-hmm.
is reliable.
Calibrated means,
There
there
are
are
RFID
instrument.
card.
Yes, yes,
RFID
yes.
cards
But
comes with a kit.
I am coming to that also. So
Hmm.
they are calibrated, but you can ask for the calibrated calibration card also. These instrument having a calibration card. Okay. So
Hmm.
you can ask for the company for the calibration card also. So that whenever you need to be calibrated, you need a means for such instrument. I don't think you are running a QC on it, but you can run a QC, means the IQC which are you are running on the liquid chemistry. You can run that IQC on that card also, right?
Hmm.
Okay, like suppose there is a card for means CRP, as you said. So
Hmm.
there is CRP, CRP का IQC जो भी होगा, whatever the IQC of CRP is, means when you are whatever IQC are running in a lab, if that IQC contains the control for CRP also, that means जो IQC आपने लिया, that you can run on the card also, same way. So you can match the value with the IQC values. Okay, so that way you can get the idea whether the card machine is running well or not, machine is giving the accurate value or not. Okay, but suppose that value is not fine, that value is derailed, that value is not matching accordingly to the mean of the IQC, then you can ask for the calibration card. Always there are the calibration card with the company. You can ask for it.
नहीं, मैंने पूछा था उनको कि ये कैसा कैलिब्रेट, यू डोंट वेस्ट वन टेस्ट फॉर दैट, फॉर कैलिब्रेशन. So you just put a card, just like
Yes,
our cell counter.
yes,
Just the
yes,
instrument says calibrated. Okay, you can
yes.
run the next sample. Not necessary to waste one test for calibration. My
Okay.
question is only, my question is, it is reliable or not?
No. You have to calibrate any instrument. In any instrument, you cannot run through for months without calibration or without checking its quality, because somewhere the values are deviant and it is not reliable. And I also tell you reporting a card values are somewhere some district has banned
Yes, yes,
that you cannot report the card values, right? Am I right? Some because
yes.
few
So
places you
that's why
cannot report
I'm doubtful for the calibration.
Yes, of
I
course.
also not check IQC.
That is one of the reason that cards are not trusted. Okay, so that's why they have banned, because they know that people are not wasting. Means I had also a machine that was a card based machine for thyroid profile TFT. So that one card was about 250 or 300 rupees. It was like TSH, and if you put a control on that card and put one card, this is 300 is wasted, right? So that is what suggested to you also, I think, by the dealer, that why you have to waste one card. Just uh, keep on running it. It is a calibrated instrument, but it is not that way. If there are administration which is instructing you that you cannot report the values, card values, that means there are some errors because of which they have given that instruction. Because sir, कोई भी law ऐसे ही तो pass नहीं कर सकते. They might have checked it. That's why they have passed that statement.
Yes. That is also
है
true.
ना? हाँ.
Thank you.
Hope,
Thanks a lot.
Okay.
Yes, ma'am, we have another question, like which control should we use of POC and what will be the frequency of that control? Someone asked that question in the chat box. So can you give
1 minute here. Which control is used for?
point of care testing? POC.
Which control? POC you can use level 2 control. Okay, these controls are used for point care testing. Whatever control we are using here inside our lab, reconstitute it and you can use for POC. It's not, but you have to match. But if it is a like qualitative test, then for qualitative test you don't have any IQC for that. But for quantitative test, point care testing like glucometer or some other test, you can use these controls. Okay.
And what will be the frequency of it, ma'am?
Frequency. If it is called again, I am saying if it is a card based test, frequency of the card based are 65 to 70% accuracy.
Okay.
So it is like POC is always like SOS type of testing. Means suddenly a patient need a care, then we go for POC. Otherwise, it is suggested to go for quantitative testing. So we can find out the accurate values. For the diagnosis, we need proper investigations. For means like for the patient care, we can go POC. We have, but if for the diagnosis, we have to go for investigation, proper investigation.
Thank you, ma'am. I think we have a yet another question to you, that how to check a linearity as a multiple standard are not provided.
Multiple standards are not provided, so you have to check the linearity. So you are talking about means semi-auto, right, Jayant?
Yes, he said.
Okay, fine. So, Jayant, if you are talking about the semi-auto and you have don't have the multiple standards, means like that. So, linearity cannot be checked with the single standard. Okay, and for multiple standards means if you are working in a means medical laboratory, so I think dilution may be problem for, because from a single standard we make many concentration by diluting it, and we can go to the graph for that. And if we put out the linear curve for that graph, then from that we can check a linearity for that sample. Or you can also go by diluting the sample also. Okay. By single standard, you can check by diluting the sample also. And in a particular you can check that whether till which dilution the values are giving fine. But first of all, you have to find out the accurate value of the sample. Further, you can go with the dilution. Okay, and glucometer is a capillary blood. Won't it be the difference? It will be the difference, but control has a particular value. You don't have to go for diagnosis for the any patient. You have to check the match the value of the control from the glucometer, just to find out whether the glucometer is working perfectly or not. This is the answer for zonal ratio. Okay, so it is, we are not diagnosing the value for any patient. Here we are checking the glucometer. That's why I said to check the control. So the whatever the value glucometer will give, we can match that value with the means value of the control. Sonal, I think you are satisfied with the answer, or further you have any question you can ask.
Yes, Mr. Dhanaji, you can go ahead with your
Yeah,
question.
I am satisfied, but so basically we can see the trend. That's what you're saying.
Yes, yes, yes. We can see the trend, and it is not like we are diagnosing a patient. We are just checking our instrument. See, NABL have just give the revised guidelines or POC, instrument point care of testing. So how it is giving the accreditation, because since my lab is not NABL accredited till now, but we are going trying for it very much. But recently, what are the trend? What is the means? How it is giving the accreditation for POC? It has to be check for instruments whether they are means they are soon going to means companies are means like arranging for POC controls also. So for NABL accreditation. Okay, so because now it has been started, so further it will go with the POC controls also. And second thing is that you can, with POC, we can go for the inter-lab or intra-lab comparison also. That can be done. So that can be checked, and NABL is now accepting that intra-lab comparison, inter-lab comparison.
Yes, Dhanaji sir. So this will be a last question of the series. So Dhanaji sir, you can ask your questions, or if you want to ask like more question, you can like write in the chat box, and we will sure get back on this.
One more question by Dr. Sayyed. As I said, the accuracy for 65%. See, again, I will say that POC is just for patient care, not for diagnosis. So, if we are giving a diagnostic reports, then I won't suggest you to keep POC instrument in your laboratory, because many states have banned the POC reports. You cannot give diagnostic report on POC instrument.
Thanks. I think he is satisfied with the answer. And
Yes, sir.
we'll take a last question now from Mr. Dhanaji. Yes, Dhanaji, can you hear us? You can ask your question. I think we have just lost him due to some network issue. Is there
Okay,
any
okay, okay.
last question, or
Uh,
we will?
yeah, I have one question, Dr. Parul.
Yes.
Ma'am, we understand the importance of EQUAS. So I just wanted to ask, ma'am, that whenever we are running the EQUAS, so as a company also, our QC department and QA department also run a QA, EQUAS, and we have our reports, right? Like we get our complete report, and so ma'am, will this be like when we sell the product to the customer? Will that be any advantage to the customer that when we are saying that, okay, our product is passed through the EQUAS, internal quality control, and rigorous QC is already done. So can we have any edge over that? Like, can we educate customers on this one that why, as a company also, we are doing EQUAS?
Okay. Yes, yes, I know that. And yes, of course, that is a better way to sell the product, I think, because for the reagent satisfaction, like I have given the points that check the reagent when your LJ charts are fine, then IQC fine. At that point, you can say ki, you won't get any complaint from the our reagents. Okay, our agents are totally fine, and they are accurate, sensitive, and good linearity. So at that, you can give that promise to the customer on the basis of reason. So that one part is eliminated for their means preventive or corrective action.
Okay, okay. And ma'am, any ranking, that ranking does matter, like any rankings are there for that one, EQUAS?
Ranking for
EQUAS, if you're running any EQUAS, so does the rankings are there which can be like beneficial for us? If do they give any
company
ranking?
ranking, company
Yeah,
ranking.
yeah.
I don't think so. There are any ranking for it. It is
No, no.
like
If we run the EQUAS, so in the peer group, they would give any rankings
no,
to
no, no, no. They
no.
don't give any ranking because peer group is like whatever the mean result they give for that
Mm,
particular means analyte. That peer group means is of that mean is from the results from all the means instrument in that peer group. So there
correct.
is no ranking because means like I have some my lab has some value, other has some value. There are 10 instruments in that peer group. So mean there are 10 mean for 10 instrument, right? Okay, so that is the mean they have taken. There are 10 values and mean of for that 10 values has been given in the peer group. So there is no ranking actually. The CAS का कोई means manufacturer mean नहीं होता. They give the mean of the peer group only.
Okay, absolutely. Thank you so much, ma'am,
Okay.
because
Okay.
we generally share it with our team. So I just wanted to give confidence to my team as well that if we're running a EQUAS at back end also, like it is advantages for customer as well.
Of course, from reagent thing, you can promise the customer that our reagents won't give any means like problem regarding the CAS or regarding deterioration. Means some reagents are deteriorating because it's their nature, like creatinine, like bilirubin. So it's
Absolutely. Correct,
yeah.
correct.
So you have to maintain the storage according to that, and they are needed to be calibrated. But which are not needed, then on that you can give the promise to the customer that it is like our agents are fine. that has passed the ICAS also. The customer, see, a lab who is, there are two kinds of lab, and two kind of people who are running lab. One is like on the totally on the means commercial. I know everybody is there in the market to means earn, but there are few who understand the maintenance of the quality. So one who understand the maintenance of quality will always understand that your reagent has passed the IQAS. Getting my point? But one
Yes.
who haven't understand the means importance of the quality will go for according to the price of the reagent.
Okay.
Okay,
Okay. So,
so you decide what customer you want. That is up to you.
okay, okay, absolutely. So, ma'am, for the benefit of this audience, like, ma'am, there are like many e-cars are present, like Pyred and Randox, and now the CSC is quite a popular one. So, like, do you
Mhm.
recommend any or any particular e-cars, or like we can choose any e-cars program?
See, I have worked with the CMC Valor also. I have worked with the Randox also. So I felt Randox because this is my experience.
Yes,
Randox
yes.
because is better because Randox because is also give the your performance in the peer group, not
Okay,
ranking but performance. Okay,
okay.
means how much you perform in your peer group. That also report. So you can understand it out of 100, out of 10, whatever is the means number of that peer group. You can understand that where we stand.
Oh, absolutely.
Okay, so this is the
Yeah.
comparison between the two cars on which I have worked. As I have said that I am sharing my experiences. So
Yes, yes,
this is
absolutely,
my
ma'am,
experience.
absolutely. At least, yeah, yeah, you're sharing experience, and like we get to know so many things. Like we day to day, the team is working, but sharing experience always help. So, ma'am, thank you very much for this wonderful session. We have our managing director also in the call with us. So, Abhinav sir, are you there in the call? You can, uh, you're not audible, sir. Oh, I think we have some network issue. Um, No problem, ma'am. So I think we can wrap it up. Thank you for a wonderful time. 1 hour. I mean, everybody was listening very peacefully. Your voice. Uh, okay.
Ma'am, you
You're
are on mute.
you're on mute.
Am I audible? No.
Yeah, yeah, ma'am.
So one question is from Dr. Sayed in this chat box. Actually, I could not understand the question. It's only method-wise comparison, means ICAS is asking about, right? Not
Yeah, yeah.
instrument-wise. No, it is not instrument-wise. Actually, it is instrument also because your instrument means like, see, I have a one Randox machine. So whatever model of Randox which I have, so that model will be kept in that peer group. Okay, so that peer group will be combined of that model, and according to that model and that peer group, suppose I keep the name like Randox Ebola. So Randox Imola का peer group consists of 100 of Randox Imola in the throughout the India. So that is the 100 instrument throughout the India. How you are performing in that 100, that performance is also given by them, and that is the not it is a comparison. It is actually performance. You cannot say it is comparison. It is performance that is given in the class, that how well you are performing, how much well your quality is performing within that peer group.
We come to an end, ma'am. Thank you. We just passed 1 hour. Everybody was
Yes.
listening very carefully. Thank you for the wonderful session, and
Thank you so much.
we will in future also we'll love to hear from you a lot. And many people are asking for the PPT, so we'll definitely share the PPT
Yes, yes,
of
sure, sure.
method. Yes. Thank you, ma'am, once again for giving your precious time, and thank you, audience, for joining us. at 4 o'clock. Like a lot of people have work, but they've joined it. So thank you everyone once again. Thank you, madam.
Thank you so much.
Thank you.
Thank you, ma'am.